fluids will be divided in three sections. The first section will be called hydrostatics. The word hydrostatics means that the fluid will be at rest or stationary, in equilibrium, so it won't be moving. The second, and this will be based on the Pascal principle. Pascal principle. The second topic, the hydrostatics, will be based on Pascal principle. So the one that they pretty much study the whole topic, or the greatest research on that, was due to Pascal. Blaise Pascal is a scientist. Have you heard? Okay, the second topic will be called, or will be called buoyancy, and will be based on Archimedes principle. Have you heard about Archimedes? Okay, Archimedes principle. And the third principle, or the third topic, will be hydrodynamics. And will be based on Bernoulli's. Which is the Bernoulli's principle. Which means that the liquid or the fluid won't be at rest. That's what we call hydrodynamics. So these are the three topics we will cover here in fluids, the behavior of fluids. To start with, let's start talking about hydrostatics. The fluid will be at rest. Fluid is a liquid or gas. In the liquid or gas will be more important than to talk about the mass of the fluid, the density of the fluid. The density, when we are talking about volume density, we know that is the mass over the volume. Since the fluid occupies volume, occupies space, we will talk about the volume density. The unit, very important, always international, is kilogram per meter cube. But also, you can find, very common in chemistry or physics, also the unit gram per centimeter cube. How do you convert from one unit to another? So always, most of the time, you will need to bring this from here to here. Why? Because the gravity will be there somehow. Since the gravity is in meter per second square, and everything else will be in Newton, so most of the time you will need to bring this unit to this unit every time that you have the gravity included in the formula. If you see gravity in the formula, you know that you have to convert from here to here. So how do you convert? First, the density of water. How much is the density of water? 1, but that unit was gram per centimeter cube. So how do we convert from here to kilogram per meter cube? We know that in 1 gram we have 10 to the negative 3 kilogram. And in 1 centimeter cube, which is 0.10 to the negative 2, we know that 1 centimeter in meter is 10 to the negative 2. If we cube that, if we cube this, will be 10 to the negative 3 times 10 to the 6. So, the density of water will be, instead of 1 gram per centimeter cube, will be 1,000 kilograms per meter cube. This is how to convert from one to the other. This is the conversion factor. For example, aluminum, I think, that is a 2.7 gram per centimeter cube. You can Google that to see if it's right or not. But I think that is the density of aluminum. 2.7 gram per centimeter cube. If I want to find what will be the density in kilogram per meter cube, what do we do? You multiply by what? 1,000. So it will be 2.7 times 10 to the third, or 2,700 kilogram per meter cube. This is how you convert from one way to another, from one unit to another. Any questions on converting? In addition to this density, sometimes you will see, instead of density, specific gravity of material. What will be the specific gravity of a material? Will be equal to the ratio of the density of any substance to the density of water. This is what we call specific gravity of the material. In other words, it's the same than the density of the substance in gram per centimeter cube without unit. So it's how more dense is the material than the water. For example, in the case of aluminum, if I want to find the specific gravity of aluminum, how much will be? The same than this, but in gram per centimeter cube. It will be 2.7, and that's it. So basically, that number, the specific gravity, tells you how more dense is the aluminum than water. By how many times? 2.7 times. This is what we call specific gravity. Good. This is the first topic. The second topic, important for fluids, is to understand that we don't talk too much about the force exerted on the fluid, because the fluid goes in one place or the other. When you exert a force, this is important, but that force, instead of force, we will use another term for fluid, which is called pressure. The pressure, by definition, is the amount of force perpendicularly acting on a cross-sectional area. So imagine that I have this here. What will be a pressure? It's the amount of force that I am exerting on a certain area. This is what